So what if your company's supply chain, your quality control, and your logistics were all just currently being run by autonomous systems negotiating with each other in real time?
Like right now.
Yeah, right this second.
Yeah.
And we aren't talking about, software running on some pre-programmed autopilot. We're talking about active, like split-second decision-making.
Yeah.
Systems that are literally debating resource allocation, altering shipping routes, adjusting production lines, and doing it without a human ever clicking a single button.
Which sounds like science fiction, I know.
It really does. But according to Gartner's latest data, 63% of enterprise organizations have already moved these agentic systems out of the pilot phase and into production.
Yeah, it's wild.
And that projection hits 78% this year.
It's a massive, it's a fundamental infrastructure shift for 2026, and it completely alters the competitive landscape.
Oh, totally.
Because if you are a European business leader or, CTO developer, the window to understand this is closing fast. Organizations that actually master this multi-agent orchestration, they're positioning themselves to dominate major tech hubs, manufacturing hubs.
Especially places like Eindhoven.
Exactly. Eindhoven is prime for this. But those that wait, they're just staring down severe operational disadvantages, not to mention massive compliance risks under the newly enforced EUAI Act.
Right. So today, we're unpacking a stack of sources from Aetherlink and Gartner to really get to the bottom of this shift.
It's a lot to cover.
It is. So our mission for this deep dive over the next, 15 minutes or so is to figure out how these multi-agent systems actually work computationally.
Right.
And why the European Union is treating them as this massive regulatory minefield. Plus, how you can actually architect these systems without facing crippling fines.
Because the fines are no joke.
They really aren't.
Yeah.
So let's start with the baseline tech. The sources distinguish between traditional AI tools and what Aetherlink calls Etherbot solutions or Agentic AI.
Yeah.
If I'm a developer, actually writing the code, what is the mechanical difference between a standard chatbot and an agentic system?
So the defining mechanical difference comes down to autonomy and statefulness.
Unpack that.
Well, a traditional conversational AI is essentially just a reactive function. It sits idle, right?
Like it's just waiting for me.
Exactly. You input a prompt, it processes that prompt against its training data, generates a response, and then it basically goes back to sleep.
Right.
It doesn't have an ongoing objective.
Right.
But an agentic system, that operates on a continuous perception action loop.
Perception action.
Okay. You give it a parameterized goal. So say you tell it, minimize supply chain disruptions for component X while keeping warehousing costs below Y.
So it's a very specific ongoing mandate.
Right. The agent autonomously perceives its environment by pulling real-time data from APIs. It formulates a sequence of steps to achieve that specific goal, executes those actions, and this is the crucial part. It evaluates the outcome of its own actions to adjust its next move.
Okay, so it's actively managing a state.
Exactly.
It's holding a memory of its previous actions. It's actually doing the work rather than just, generating text about the work.
It is. And they operate across multiple modalities, too, integrating what Aetherlink defines as AI perception and action frameworks.
Which means what, practically?
It means they process visual data from cameras, acoustic data from factory floors, text from supplier emails.
Wow, all at once.
Yeah, but the complexity scales exponentially when you deploy dozens of these specialized agents simultaneously.
Right, because they're all doing their own thing.
Exactly, which is why that requires what we call multi-agent orchestration.
Right, which is the system that keeps them all in check.
Exact.
I want to build a clear picture of this for you listening, because instead of comparing it to, corporate middle management, let's think about it computationally.
Okay.
Like an automated air traffic control system.
Oh, that's a good way to look at it.
Right. Because you have dozens of individual planes, and these are your specialized agents. One plane is your logistics agent, and it's flying its own route. Another plane is your quality control agent.
Yep.
And they all have different destinations and entirely different priorities.
Right. They don't naturally care about each other's goals.
Exactly.
Yeah.
So the orchestration platform is the air traffic control algorithm. It monitors altitude, speed, trajectory for every single plane.
Yeah.
And if two planes are on a collision course, that control plane calculates the safest adjustment and dictates new parameters so they literally don't crash into each other.
That analogy actually captures the technical reality beautifully. Because without a really sophisticated control plane governing the communication protocols and resource limits, multi-agent systems will inevitably crash your operations.
Right, they'll just gridlock.
Exactly. If you look at complex manufacturing environments, say in Eindhoven, you have agents managing semiconductor fabrication, right?
Yeah.
If the logistics agent decides to reroute a massive shipment of silicon to save money,
Which is its job.
right, that's its goal. But if the predictive maintenance agent has already scheduled a machine downtime that requires those materials immediately, you have a critical system conflict.
Oh, I see.
Yeah, the orchestration layer provides the overarching logic to prevent that exact gridlock.
Well, the logic makes total sense on paper, but I'm looking at the adoption numbers and the sources we have, and it's a bit surprising.
Yeah, the European numbers.
Right. I mean, a place like Eindhoven attracts, what, 2.8 billion euros in annual R&D investment?
Something like that, yeah. It's an absolute powerhouse.
It is. Yet, enterprise adoption of these agentic systems in European hubs is lagging significantly behind places like the US and Singapore.
Yeah, well, the hesitation in Europe is almost entirely driven by the regulatory environment right now.
Ah, the EUAI Act.
Exactly. We are hitting the EUAI Act's 2026 deadline for systems classified as high risk.
Okay.
Forrester Research actually notes that 71% of European enterprises view regulatory compliance as their single biggest roadblock for agentic systems. And the really concerning metric, the one that stands out, is that only 18% of those organizations currently have the governance frameworks required to run them legally.
Wait, 18? I had to read that metric twice when I was looking through the sources to make sure I wasn't, misinterpreting it.
No, it's 18%.
If only 18% are prepared, that means over 80% of these massive enterprises are essentially flying blind into a regulatory wall.
Yeah, they are, because the EUAI Act is uncompromising when it comes to autonomy.
In what way?
Well, if an orchestrated multi-agent system is making decisions that impact physical safety, workforce employment, or critical resource allocation, it automatically falls under the high-risk category.
Okay, so a lot of use cases.
Almost all of the highly profitable ones. And you can't just deploy the model and see what happens anymore.
Right.
The law demands documented risk assessments, continuous bias auditing, mandated human-in-the-loop escalation paths.
That sounds exhausting.
It's forensic-level audit trails for every single decision the agents make.
See, if I'm a CTO sitting in Eindhoven reading these requirements, my first instinct is to just slam on the brakes.
I mean, that's the natural reaction.
Right. If the compliance burden is this mathematically complex and the penalties for violating the act are catastrophic, why shouldn't I just wait?
Because waiting is...
Seriously, let the companies in the US and Singapore be the beta testers. Let my competitors risk the massive fines while the courts figure out the exact rules, right?
Right.
And then I'll just adopt the standardized, legally safe version a few years from now.
I get the logic, but the problem with that assumption is that it treats AI adoption like buying off-the-shelf software.
Okay, how so?
The European Commission actually analyzed this 2026 regulatory paradox. Early adopters do face intense scrutiny, yes.
Obviously.
But they are also accumulating a massive data moat. They are training their orchestrators on the unique, very specific variables of their own supply chains.
Ah, so their AI gets smarter about their specific business.
Exactly. Late adopters might get clearer legal rules in 3 years, but they forfeit years of compound operational learning. You cannot buy 3 years of multi-agent refinement off a shelf.
I see.
The solution to the compliance trap isn't to wait. The solution is what the sources call AI-led architecture.
AI-led architecture.
Yeah, specifically utilizing frameworks like Aetherlink's Aethermind.
Let's demystify that term because it sounds a bit jargon-heavy. What does AI-led architecture actually mean for a developer building this?
Sure.
Are we talking about a new coding language, or is it just like a strategic buzzword for having a really good legal team?
No, it is entirely about system design. AI-led architecture means translating legal and regulatory constraints into hard-coded system parameters from the very first line of code.
Wait, literally coding the law into the system?
Exactly. You don't build an inventory agent and then ask your legal team to review its outputs later.
Right, that's the old way.
You code the compliance directly into the agent's action space. So, if the EUAI Act mandates human oversight for high-risk financial decisions, which it does.
Right. Then your Aethermind framework dictates that the agent's code literally will not compile or execute a transaction above a certain risk score without querying an API that requires a cryptographic signature from a human manager.
Oh, wow. So it physically can't break the law.
Exactly. Compliance becomes a technical dependency, not just a policy document sitting in HR.
Okay, so if compliance from inception is the only way to survive this, What does that actually look like when it's executed at scale?
It looks incredible when done right.
Well, let's look at the 850 million euro manufacturer detailed in the sources.
Yeah, the Eindhoven case study.
Right. They have 6 different production facilities across Europe. And before orchestration, every facility was totally siloed.
Completely disconnected.
And they were losing 12 million euros a year to pure inefficiency. Like excess inventory rotting in one warehouse while another facility down the road couldn't meet demand. Plus massive transportation overlap.
Right, just a logistical nightmare.
So they overhauled their entire infrastructure using a multi-agent orchestration platform, right? They did. They deployed demand forecasting agents to ingest real-time market signals. They had inventory optimization agents monitoring stock and storage costs at all 6 locations simultaneously.
Yeah.
And logistics agents calculating real-time transport routes, all governed by a centralized orchestration plane.
Now, I read this case study, and honestly, setting up independent agents for logistics and inventory sounds like a recipe for a localized civil war on the factory floor.
It can be.
Because they have competing objectives. The inventory agent's parameters likely, ensure we never run out of stock, so it naturally wants to hoard materials.
Yes, it does.
But the logistics agent's parameter is minimize transport costs, so it doesn't want to move anything unless absolutely necessary.
Exactly.
So how does the control plane actually mediate that without crashing the whole system?
It all comes down to unified cost functions and global business rules.
Okay, explain that.
The agents don't debate in English, right? They submit utility scores.
Utility scores.
Yeah. So the inventory agent calculates that running out of a critical component carries a financial risk penalty of, say, 50,000 euros.
Okay.
Meanwhile, the logistics agent calculates that moving the component today costs 10,000 euros in expedited shipping.
I see where this is going.
Right. The orchestration layer ingests both of those mathematical proposals, applies a global policy weight, like maybe the board has dictated that cash flow is the priority this quarter, and the algorithm calculates the optimal path based on that.
Wow.
So the orchestrator throttles the inventory agent's purchasing capability and forces a delayed shipment. It resolves the conflict algorithmically in milliseconds.
That is wild. And the results they achieved with that architecture are, frankly, the kind of metrics that usually get a CTO promoted.
Or fired if they turn out to be fake.
Seriously. In just 8 months, they saw a 22% reduction in excess inventory.
Massive.
18% faster order fulfillment, and they cut transportation redundancies by 31%.
In 8 months.
But it brings me right back to the regulation. If these autonomous agents are constantly executing high-risk financial and logistical decisions all day, every day,
Yeah.
how did this company survive the EUAI Act audits?
Because they embedded transparency modules into the architecture from the start.
Transparency modules.
Right. When the EU regulators look at a high-risk system, they don't just want to see the outcome. They want to see the mathematical rationale.
The why behind the decision.
Exactly. In this case study, every single decision generated by the orchestrator included what's called a counterfactual explanation.
Okay, explain how a counterfactual works in this context, because I think people get tripped up on that word.
Sure. Instead of the system just outputting a simple log that says, ordered 5,000 silicon wafers on Tuesday.
Which is what a normal software log would say.
Right. The transparency module outputs a detailed breakdown. It says, I ordered 5,000 wafers. I would have ordered 10,000 wafers if the supplier's price had been 2% lower, or if the predictive maintenance agent hadn't flagged a potential machine failure for next week.
Oh, wow.
Yeah, it provides the exact delta of what would have needed to change in the data environment to trigger an alternative decision.
So it's essentially proving its own logic.
Exactly. That level of forensic explainability satisfies the regulatory audit because it proves the AI is operating within logical, clearly defined bounds.
Right. But what if the AI encounters a scenario that falls completely outside those bounds?
Well, that triggers the human escalation protocol.
The human-in-the-loop stuff.
Yes. The orchestration layer constantly tracks confidence intervals.
Okay.
If a demand forecasting agent detects a market anomaly, say, a sudden geopolitical event spikes raw material costs, and its predictive confidence drops below a hard-coded 85% threshold.
That's dope.
The architecture physically prevents the agent from executing a purchase. It freezes the action and routes a localized summary to a human procurement officer for manual review.
See, the logic of that makes total sense in a digital environment, like procurement or inventory spreadsheets.
Right.
But the sources highlight that the real challenge, like the final operational hurdle, is the physical environment.
Yes, the physical world is messy.
Right. What happens when these systems transition from optimizing spreadsheets to controlling physical machinery on a loud factory floor?
This introduces what engineers call the perception-action gap.
The perception-action gap.
Absolutely.
Okay.
We are seeing massive advancements in multimodal sensing right now. You have robotic systems and edge devices utilizing optical cameras, thermal sensors, acoustic monitors.
Just vacuuming up data?
Exactly. They pull all this environmental data into the orchestration layer, so the AI can perceive the physical world with incredible fidelity.
But that's just the perception part.
Right. The bottleneck is safely translating that perception into a physical action.
Because, like, an agent might use a high-resolution camera to accurately perceive a millimeter defect on a production line.
Sure, easily.
But recognizing a flaw and possessing the systemic authority to unilaterally kill power to a multi-million-euro manufacturing line, those are two completely different things.
Exactly the distinction that matters. Effective orchestration requires mapping perception capabilities against strict action permissions.
So limiting what it can actually do.
Exactly. The agent's neural network might be 99% confident it sees a defect, but the action parameters dictate it only has permission to throttle the machine's speed by 10% and instantly ping a human supervisor rather than just shutting down the grid completely.
It's like the difference between giving a brilliant intern the company credit card
Oh, I like that.
versus giving them the routing numbers to the corporate bank account.
Right.
You know they're smart, you know they can analyze the data,
Yeah.
but you still set explicit spending limits based on their role.
Exactly. The AI agents require those exact same rigid role-based access controls.
Makes sense.
And managing those controls on a loud, dynamic factory floor is actually leading to a huge surge in conversational voice agents.
Voice agent, like a smart speaker.
No, we aren't referring to a smart speaker that tells you the weather. These are agentic voice interfaces connected directly to the Aetherbot orchestration layer.
Okay, I have to challenge the practicality of that.
Go for it.
A factory floor in Eindhoven is loud, it's chaotic, and it's heavily unionized.
Very true.
A supervisor is supposed to just walk around having a verbal conversation with the factory's neural network
Mm-hmm.
over all that noise.
Yep.
And doesn't recording employee voices on a factory floor violate both the GDPR and the EUAI Act?
It is an absolute minefield if it's architected poorly. The compliance requires extreme precision here.
So how do they do it?
The audio processing has to happen at the edge,
Meaning on the device itself.
meaning the speech-to-text conversion happens on a local device to minimize latency and ensure raw audio files aren't being perpetually stored on some cloud server somewhere.
Which handles the GDPR concern.
Exactly. No stored recordings, no privacy breach.
And what about the noise issue?
The systems use advanced acoustic filtering to isolate the specific frequency of the supervisor's voice.
Like noise cancellation on steroids.
Basically, when the supervisor says, "Halt line 4, run diagnostic on the thermal sensor," the edge device transcribes that intent, pings the orchestration layer to verify that this specific user's voice print has the cryptographic authority to issue that command.
Oh, voice prints.
Right, and then it executes it. But to your point on the EUAI Act, this triggers intense bias auditing.
Because of accents?
Yes, you have to mathematically prove your voice recognition models don't have higher failure rates for non-native speakers or regional accents within your workforce.
Right.
If the system routinely fails to understand a specific demographic of your employees, you are in direct violation of algorithmic fairness mandates.
Wow. Which really forces us to look at the human element of this entire shift.
It's the most important part.
Because whenever you introduce autonomous systems that can perceive the environment, analyze the data, and execute physical actions, the immediate anxiety across the workforce is replacement.
Naturally. But if leadership frames multi-agent orchestration as a headcount reduction tool, the implementation will fail.
100%.
The cultural resistance alone will destroy the ROI. The most mature organizations deploying these architectures frame them entirely around augmentation.
Augmentation, not replacement.
Right. The orchestration layer is designed to automate the millions of micro decisions, the inventory routing, the temperature adjustments, the compliance logging.
The tedious stuff.
Exactly. The goal is to strip the robotic tasks away from the humans so your workforce can focus on macro strategy, anomaly resolution, and complex judgment calls.
Things the AI is mathematically incapable of doing.
Precisely.
But elevating the workforce to that level requires a massive reskilling effort, doesn't it?
It does.
The sources point out that AI literacy has to permeate the entire organization. Like, your procurement team doesn't need to know how to code in Python.
No, Definitely not.
But they absolutely need to understand how to read a counterfactual explanation from the orchestration layer.
Yes.
They need to know what an audit trail actually verifies, and precisely how to override an autonomous agent if the system's confidence interval drops.
It really becomes institutional knowledge. If you are deploying an Ethermind framework, your developers are essentially writing the constitution that governs how these agents negotiate with each other.
I love that framing. A constitution.
Yeah, and your workforce needs to understand the laws of that constitution. Because if an organization lacks the internal expertise to map regulatory requirements to system architecture, attempting to build this in-house is incredibly dangerous.
I can imagine.
The financial cost of having to tear down a non-compliant multi-agent network after a regulatory audit, it far exceeds the cost of just partnering with specialized development teams to architect it correctly from inception.
It is a massive structural shift.
It really is.
We've covered the mechanics of agentic AI, the complexities of multi-agent orchestration, the realities of the 2026 regulatory paradox, and of course that physical perception action gap.
A lot of ground covered.
Seriously. So if you have to distill all of these sources down to a single critical takeaway for the business leaders and developers listening right now, what is it?
The central narrative here is that governance is no longer a legal afterthought. It is an engineering prerequisite.
Say that again, an engineering prerequisite.
Yes. Under the EUAI Act, you cannot bolt transparency, explainability, or human escalation triggers onto an agentic system after the fact.
Right, it's too late by then.
If those constraints are not coded into the fundamental architecture of your orchestration platform from day one, you're building a system that is mathematically ungovernable and guaranteed to fail an audit.
That's a sobering thought. My takeaway really focuses on the absolute necessity of getting that architecture right, because the upside is just unprecedented.
Oh, absolutely.
The 850 million euro manufacturer we discussed proves that when you move from isolated AI experiments to a fully orchestrated, compliant multi-agent network, the speed and scale of the operational return is staggering.
Truly.
Like trimming 22% of excess inventory across 6 facilities in 8 months isn't just an efficiency gain. It's a total recalibration of how a company competes.
It changes the baseline for survival in these markets.
It absolutely does. And that brings us to a final thought for you to consider regarding your own infrastructure.
Okay.
If your competitors' autonomous agents are already operating in a governed orchestration layer, negotiating with suppliers, mathematically resolving logistical conflicts, and optimizing production 24 hours a day, what is the true cost to your organization of keeping those workflows manual for another year?
It's a huge question.
It really is. For more AI insights, visit AetherLink.ai.